Alrighty, everybody. So today we have lesson 5-4, which is all about polygons and angles. So what I want you to do is start up with the vocabulary startup. It says a polygon is a simple closed figure formed by 3 or more line segments. So remember, line segments are straight lines. The segments intersect only at their endpoints. So it says a map of the United States is shown. List the states that are in the shape of a polygon. Then list the number of segments that form the polygon. So the first one that I can see here is Utah. Okay, so I'm going to list Utah. And we have to say how many sides there are. So 1, 2, 3, 4, 5, 6. So Utah has 6 segments. Okay, another one I see is Colorado, which is right next to it. And that has 4 sides to it. Okay, another one I see is New Mexico. And that has 1, 2, 3, 4, 5, 6, 7, 8. Then I see Wyoming has 4. And then I see North Dakota also has 4. Okay, go ahead and flip to the next page. So here at the top, it says interior angle sums of a polygon. The sum, which remember sum means answer to an addition problem, of the measures of the interior angles of a polygon. So this isn't talking about a triangle, it's talking about any polygon. Any polygon. It can be a triangle, but it's not specifically just talking about a triangle. Is n minus 2 in parentheses times 180. And this is where n represents the number of sides. So for our formula, this is a big thing. The S is equal to, so the sum of the measures of the angles is equal to the number of sides minus 2, and then all of that times 180. So it says you can use the sum of the angle measures of a triangle to find the sum of the interior angle measures of various polygons. A polygon that is equilateral, okay, which means all sides are the same length, and equiangular, which means all angles have the same measure, is called a regular polygon. So that means when all the sides and all the angles are exactly the same, it's a regular polygon. So here we are using the formula. So the number of sides we know for a triangle is 3. There is 1 triangle in it, so we had 1 times 180 is equal to 180 degrees. We know that all the sides added up equal 180. Here, for a 4-sided figure, we could split it in half, and there are 2 triangles. So we had 2 times 180 is equal to 360. A 5-sided figure, you can split into 3 different triangles, so 3 times 180 is equal to 540. And then a 6-sided figure, there's 4 triangles, so that'd be 4 times 180. So as you can see, if there are 6 sides, our formula of n minus 2 times 180 goes into effect. So it'd be 6 minus 2 times 180. So that would also mean like 4 times 180, which is exactly what we had up here. Okay? So it says find the sum of the measures of the interior angles of a decagon. Okay, so a decagon, if you don't already know, has 10 sides. So if we're using our formula, we'd have S is equal to, parentheses, 10 minus 2 times 180. So 10 minus 2, we know is 8. And 8 times 180 is 1,440. So that would mean the sum of the interior angles of a decagon is 1,440 degrees. So that would be our final answer. Okay, so this next section, it says got it. It says find the sum of the interior angle measures of each polygon. So a hexagon, if you are unsure, is 6-sided. An octagon is 8-sided. And a 15-gon is 15-sided. So for a hexagon, we have our S is equal to our number of sides, which is 6, minus 2 times 180. So we would have 4 times 180, and that would equal 720 degrees. So for A, we would write 720 degrees. Okay, then for B, we have an octagon. So same formula, you're just putting 8 in for N. So 8 minus 2 times 180. So we would get 6 times 180, and that would give us a total of 1,080 degrees. So that's what I would write on my answer for letter B, so 1,080 degrees. And then letter C, I'd have 15-gon. So same formula again, so I'd have 15 minus 2 times 180. So I would get 13 times 180. And that would equal 2,340 degrees. So for letter C, 2,340 degrees. Okay, you should be using a calculator for these. So when we get to the practice problems, I'm going to have you actually do these on your own. Okay, go ahead and turn the page. Okay, so at the top it says each chamber of a bee honeycomb is a regular hexagon. Remember, regular means all sides are equal and all angles are equal. It says find the measure of an interior angle of a regular hexagon. So we want to find the measure of one interior angle. Okay, so step 1, we're going to find the sum of the interior angles. So we know a hexagon has 6 sides, so we'd have 6 minus 2 times 180, which would give us 4 times 180, and 4 times 180 would equal 720 degrees. So this is the total of all angles equals 720 degrees. But in a regular hexagon, we know that there are 6 sides, so that means that there are also 6 angles. So I would take my 720, which is all of my angles added up together, divide it by 6, because that's the total number of angles, and we would get the measure of one angle, which is 120 degrees. So one angle in a regular hexagon is 120 degrees. Okay, this next part, it says find the measure of one interior angle in each regular polygon. Remember, all sides are congruent and all angles are congruent. Round to the nearest tenth if necessary. So an octagon is 8 sides. A heptagon, so it's a little bit different than a hexagon. A heptagon has 7 sides, and then a 20gon has 20 sides. Okay, so same thing as before, you're going to find the sum of the measures of an octagon, heptagon, and a 20gon, and then divide by how many total angles there are, which is the same as the side. So divide by 8 for an octagon, divide by 7 for a heptagon, divide by 20 for a 20gon. Now I would like you to go ahead and pause this video and figure these out on your own. Okay, welcome back. So for an octagon, one measure of one angle in an octagon is 135 degrees. For E, for a heptagon, it's 128.6 degrees for one angle in a heptagon. And then a 20gon would be 162 degrees. Okay, all right. Exterior angles of a polygon. So it says in a polygon, the sum of the measures of the exterior angles 1 at each vertex is 360 degrees. So if you look at this pentagon, I have an exterior angle of 1, 2, 3, 4, and 5. When I add all those up, I get 360 degrees. So it says, regardless of the number of sides in a polygon, the sum of the exterior angle measures is equal to 360. So in a triangle, it's like what we're going to do is extend our lines, and all of those angles add up to equal 360. So in a triangle, still equals 360 when we have 3 angles. In a quadrilateral, we still have 4 angles, and that still equals 360 degrees. Okay, go ahead and turn the page. Okay, so example 3, it says find the measure of an exterior angle, so an exterior angle in a regular hexagon. So it says let x represent the measure of each exterior angle. We know that a hexagon has 6 sides, so I have 6x, and we know that all the exterior angles are going to add up to equal 360, so our x is 60 degrees. So it says each exterior angle of a regular hexagon measures 60 degrees. So for the goddess, when we find the measures of an exterior angle of each regular polygon, we know they have all the same sides and the same angles. So for this, for a triangle, we would have 3x is equal to 360. And when you divide by 3, x would equal 120 degrees. For a quadrilateral, we know that's 4 sides. So we would have 4x equals 360. Divide by 4, and we get x is equal to 90. Then an octagon we know is 8 sides, so we would have 8x is equal to 360. Divide by 8, and x is equal to 45 degrees. So I would write on my lines 120, 90 degrees, and 45 degrees. Okay, I would like you to go ahead and do problems 1, 2, 3, 4, and 5 on your own. So I'd like you to go ahead and pause this video again and figure out those 5 problems. And when you're ready, come back and I would like you to check your answers. Alrighty, welcome back. So the sum of the measures of each polygon for a quadrilateral is 360. A nonagon is 1,260, and a 12gon is 1,800 degrees. For 4, it says what is the measure of one interior angle of an equilateral triangle? That would be 60 degrees. And find the measure of an exterior angle of a regular pentagon. That would be 72 degrees. Thanks for watching, everybody.